The point is, what actually is happening? Superimposing means that how one wave is cancelling and the other wave is actually enhancing. But technically speaking, it only happens. Now, let's take an example of superimposing in constructive way. When I say constructive way, it means that the combined effect of two waves enhances. The point is, how does it enhances? It only enhances in a way that crust will superimpose on crust and trough will superimpose on trough. What my mean is, let's suppose there is a wave and there is another wave. If they are superimposing each other, it means that crust will fall on crust and trough will fall on trough. So the resultant will be like this. So technically speaking, the resultant, the effect will be enhanced rather than it's reduced. That is the reason sometimes if you see that there is an orchestra and there are multiple voices, you will have it from here and there. And if it superimposes, the effect going to be, you can say, enhanced. Or you can say the more voice is actually, you heard a more voice regarding one. You know that there is a word normally used nowadays. What is that called? HD quality, high definition. Do you heard this?
Yes, sir.
What does it mean, high definition? High definition means you're trying to superimpose the voices so that you can hear much more clear voice. Like you have two or three or four orchestras like guitar or different things. When you're trying to superimpose it, sometimes it happens that one voice actually killing the voice of another. In that way, what actually happening? One voice crust actually superimposed on the trough of the other wire. So actually, they will cancel the effect of each other. In that way, nothing can be heard properly. But sometimes it looked like it gives you a sensation that you are hearing much more clear and much more louder voice, even though the voices are not that much louder. So what actually happened in that way? In that case, the thing happening is the voice looked like a bit louder because they superimpose each other. So superimposing is what? Two waves that have amplitude, let's suppose 1.0 traveling in the opposite direction, they are just shown it, combine into a single wave to form when they overlap. If we add them or if we add these waves together, the resultant depending on where the peaks of the waves are compared to each other. Here are three examples of what are the resultant could be: a wave with the amplitude 1.5, no resultant, and wave at all, and wave with the amplitude 2. Now, if you see that, they give you three different examples. One is this, one in that, and one in this. If you see the second one, what is the result? What is this case?
The first one
No, no, second one in the middle.
is destructive.
It's destructive. We called it superimposition is destructive. Superposition is destructive. We can say crust is actually superimposing on trough of the other wave, and trough of first wave is superimposing on the crust of other wave. So technically, we have amplitudes, but in the opposite direction, and because of that, they are cancelling the effect of each other. That's the reason the resultant wave amplitude is zero. So basically, it means that if you are actually superimpose two different void in such a way, which is just shown here, you cannot hear anything. Or you may hear a sort of a noise, you will not understand a single thing. Right? If you see the second one is very interesting. You will have one wave here and the other wave here. They are actually superimposing in such a way that crust will fall on crust and trough will fall on trough. So in that way, the amplitude is doubled. If you count the amplitude, it will be doubled. So if amplitude is double, it means it's a constructive interference. You will find out in a minute. Okay. So it is superimposition or constructive superimposition. If you check it here, it's a mixed one. Some waves are half of the, for example, crust is falling on the half of the crust, and same thing, half of the trough is falling on the half of the trough. So basically, some part of it actually cancelling the effect, but some part of it actually not cancelling the effect, but actually getting the answer. So basically, they give you three different answer for these three superimpositions. Okay. So superimposing imposing are of two types. One is called as constructive, the other is called as destructive.
So
In
the
this,
first one is also constructive.
first of all, is a mixture of constructive and destructive, because some parts are destructive because the reason is they are not fully, you can say, trough is fallen on the trough and crust is fallen on the crust. They are sort of a mixed thing. That's the reason, even though both got one amplitude, the resultant is not two. But the second one, the third one is 101% fully constructive. The second one is totally destructive, crust fall on trough and trough fall on crust. Here, it's not fully constructive, neither fully destructive. The reason is some part is fall on some part of construct. I mean, some of the what do you call it? Trough part is fallen on the crust part, and some of the crust part of the one wave is fallen on the trough part of the other. So how can you say this is constructive or destructive fully? It's just a mixture of both of them. Okay. Any questions?
No, sir.
Okay. Now, another type of waves which are here. This is interesting actually. This is called a standing wave. As the name suggests, what do you think standing waves are?
No movement.
But there is a movement. How come it's no movement and we call it movement?
No energy transfer.
Actually, energy is transfer. But you know what happened? They are stuck to one specific place. Energy is not transformed everywhere. You have a limited medium, and within that medium, you will just find the wave, and that's it. Waves are not actually going further up, further as we have water or something. Like here in this case, if you see that, you have just a string which is attached from one end at this place, this point, and one end here at this point. Now this is a string. Now what happens? If you touch it or if you just pluck it, what will happen? It will form simple vibrations like this, or you can say crust or trough like this. Now if you see that, they just form crust and trough. You know why they are forming this? There should be crust and trough, but if you see that, they are actually making a kind of a node. We called it node or antinodes. Down and up, down and up. So basically what happened, when two similar waves travel in opposite directions, they can superimpose to form a standing wave. So basically, a standing wave is a stationary wave, but a stationary wave doesn't mean in that case that they are stopped. A stationary wave is simple that one wave is going further, they strike one corner and they reflect back and they superimpose the previously coming wave. So it look like, rather than a wave, they look like a loop which is coming to you. Like what my point is, here the wave is going, 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 going. It strike back and it will come back here like this. So rather than you will have a single wave going, one wave is also coming back and they are sort of superimposing each other. And when they superimpose each other, you will find sort of a loop here. This is called a full loop. Actually, this is a wave, but it is a sort of a loop here. So basically, this type of wave is called as a standing wave or a stationary wave. Understood?
Yeah.
Good. Here is an experiment setup of how we can form a standing wave on the string. The vibrational generator send a wave down the string at the certain frequency. They reach the end of the string and reflect back at the same frequency. On their way back, the two waves traveling in the opposite direction superimpose to form a standing wave made up of nodes and antinodes. Now, this is very interesting one. Once they are coming in, I mean, coming back, like for example, one wave and the second wave. On the way back, you will have a wave coming through and you will have a sort of a loop, which we called it standing wave. Now, you will have a node and antinodes. Now, what are nodes and what are antinodes? That's what our topic is for the time being. Node means position on the standing wave which do not vibrate. The waves combine to give zero displacement. Where they are giving zero displacement?
At the starting and the ending?
Yes, not starting and the ending. These are the nodes
Yeah.
where actually they meet each other, or you can say they superimpose in such a way that the resultant is zero. That's where we call that nodes. And where
So it's destructive.
definitely no, yeah, at this point we got destruction or destructive um, superposition for the timing because we I will come to the interference when it comes. By the way, this is also called interference as well. But as far as the
Yeah.
stationary and standing waves are concerned, we will use the word superposition. All right. So basically,
Yeah.
those waves or those points where you will have a destructive interference where one wave which is going forward and the one wave which is coming back both join in such a way that the displacement or resultant displacement becomes zero. Those points are called as nodes. And where they give you a combined effect in such a way that displacement got the maximum, like these points, these points. Here you got these point and these point. Now they are called as the antinodes. So now what are the things we established in a stationary wave? First of all, what is the major difference between stationary waves and the general wave? Remember that general wave when you're talking about, we called it progressive waves. Okay. First of all, in progressive wave, this is same for all the parts. They give you the example as well. Same for all the parts means there are nothing called nodes or antinodes. We do not have maximum at antinode and zero for nodes. We never have that condition in progressive wave. The same for all the parts of wave. That's the first difference. Second is all parts of the wave have the same frequency. Remember that frequency always depending upon the source. So all the parts of wave have the same frequency. This is a common point between them. Like for example, whatever I'm saying, whatever you are hearing from my side, it will never ever change until my voice will change. So frequency will always depending upon the source from where the voice is coming or from where the light is coming. So frequency never changes. Whenever it changes, it always changes the wavelength. That is the reason that is a common point between them. Whether you're talking about standing wave or whether you're talking about the progressive wave, remember that the progressive wave means longitudinal wave and transfer waves, all. Okay. Now wavelength. Twice the distance between the adjacent node, the distance between two adjacent peaks. Okay, this is very interesting. What is the wavelength in general? This is the wavelength.
Distance between a crust and a, yeah, consecutive crusts.
So you can say twice the distance between the adjacent nodes. No, not nodes, sorry. Distance between the two adjacent peaks. Because here we are talking in general. So I'm saying it a peak. Peak whether in the uh, trough form or whether in the crust form. Right? On the other side, what is
Yeah.
the wavelength? The wavelength is twice the distance between the adjacent nodes. Now this one, twice, double of it. So twice the distance between the adjacent node. Because one wave, another wave. Because one is sort of a crust and the other is sort of a trough. So if you just find that distance and multiply it by two, that distance will be from here to here. So two, you can say nodes will join to give you wavelength. Phase, which you were talking about previously. Phase means all points between two adjacent node is in phase. Adjacent node means one after another. All the points are considered to be in the phase. While on the other side, points on one wavelength apart in the wave. The point on one wavelength apart in the wave. Now, this is interesting. These points, whatever point is in here, will be in phase, or you can say apart in the phase, because they are not the same. All the phase, if you check this point is in different phase, this point is in different phase, this point is in different, this point different. All the points are having a part in the phase. They are not on the same phase. while as far as all the points between the two adjacent nodes, they are in phase. In standing wave, no energy translation. Remember that. Energy is not transferred fully. While here, energy is translated in the direction of the wave, right? Waveform does not move forward. Energy translation in the direction of wave moves forward. So these are sort of a difference between standing waves and the progressive wave. Any question regarding this?
No, sir.
Just quickly go through that and tell me if you want to have any question. Just read through it, because as we proceed further, we will go to harmonics and then second harmonic and then double. But go through this first.
So, sir, in the progressive wave, all the points, they're in different phases, or they're in the same phase but different.
No, no, no. First of all, you need to understand what is meant by phase. Let me just explain once again. See, if this is your wave, right? Which to, if for example, I'm talking about this point, then this point will be in phase with this point. Am I right?
Yeah.
So it means this point will be phased with this point. But in that case, that point you're talking about will be considered in the second wave. In one wave, you will not have the points which are in phase. So that's what they're saying. Points one wavelength apart in phase. They are distant, apart in the phase, not on the one wavelength, you can say. Points one wave apart in phase. Okay. While on the other side, all points between two adjacent nodes are in phase. If you check it out here, check this out. This is in phase. This is in phase. This is in phase. This is in phase. Here, this is not the case, because here this is in phase, but the point is they are far apart. They are at distance. But this one, they are not far apart. They are sort of in a one node, or you can say just in one complete adjacent nodes in phase. So that's what we called it, that points one wavelength apart in the phase. Like phases are a bit far. Their phases are not far, they are in one node. Okay?
Yeah.
Uh,
So the scientific definition of a phase would be um,
you see,
points that are.
when you say in phase, it means that if you draw a horizontal line, it will touch 2 points. Like for example, if I say in phase, if I say any 2 points which are in phase, you will draw a straight line. Simple. Let's suppose you want to find out about this point, which point is in phase with this point, you will draw a straight line. Wherever this touches your I mean your wave, you say this point is in phase with this point. Okay, like this is a
So
point.
adjacent, yeah,
Yeah, you're saying something.
adjacent antinodes are not in phase.
Adjacent antinodes are in phase. Same like adjacent nodes are in phase.
So the points between two different antinodes are also in phase.
Yes, because the problem in that one is it's a sort of a loop. It's not a proper wave. Like if you're talking
Yeah.
about progressive wave, you have a proper crest and trough. Here you do not have a crest and trough. You have a sort of a loop. That's why each and every point between the two adjacent nodes are 101% in phase, because they are in making a loop. In that particular wave, which is your progressive way, they are not making a loop. That's the reason they are apart in phase. If you want to find out a point which is in phase with one, what you can say, between one crust, you have to wait for one trough to pass, and then crust and crust will in phase. Do you understand what I'm saying?
Yeah. Yes.
You have to wait. That's the reason they say apart. The word used here is apart. While on the other side, it's not apart because it is a loop, a full complete loop,
Yeah.
a merger of a wave which is going forward and a wave which is coming back. So it's sort of a making a loop, properly loop, going and coming the way. That's the reason it's written all the points between two adjacent nodes in phase. On the other side, it's written points one wavelength apart in the phase. Because if you want to check which point is in phase with first wave, you have to wait for Let's suppose if it's on the crust of the first wave, you have to wave at least past the trough first, and then the wave will start. I mean, the crust will start for the second wave, and then you will check which particular point is in phase with the point on the first wave. That's the reason we called it points one wavelength apart in the phase. Now, do you understand the concept of that? What is meant by one wavelength apart?
Yeah.
Good.
So all points in the stationary wave are in phase.
Yes. Because again, I'm telling you, the reason is there is no properly crust or trough. Here we have crust or trough. So to find one phase point, you have to wait for a complete cycle to pass on, and new cycle shall start, and then you will find the point which is in phase with the first one.
Yeah.
Okay. Now the next very
Yes.
important thing, the word is harmonics here. Now, what is meant by harmonics? That's what the point is. Let's suppose you pluck it and you will find one loop, one node, I mean, two nodes and two antinodes, right? So, can I say that this is your length L, length of a string, okay? So, as we increase the frequency of vibration generator, we will see standing waves being set up. The first will occur when the generator is vibrating at a fundamental frequency. Now, this is important. This is very important. You will have one node and one antinode will form a first harmonic. First harmonic means when there will be a single wave generated. Now, if you see that one wave, the other wave, can I say that the lambda or the wavelength of this standing wave in that case will be equal to 2L? Why 2L? This length and this length. So L plus L is equal to 2L. Can I say that?
Yes.
Now remember that, always remember, as we will be proceeding further, you will find out that first harmonic means when there will be a single wave generated, or in that case, there will be single node, not single node, I mean two consecutive nodes or two consecutive antinodes are formed. All right.
Yeah.
Now let's talk about the second harmonics. Now here the number of waves increases. When the number of wave increases, the lambda will be equal to L. Why lambda will be equal to L? Because we will be finding it for one wave, right? Because we are not finding wavelength means the wavelength of the one. Actually, technically speaking, it should be 1, 2, 3, and 4. But we have to find it for one complete wave. So it shall be equal to what? It will be equal to one wave. So you divide it by 2. So it is equal to 1L. Why 1L? Because first of all, this full complete node will give you single L. This will complete give you single L. So L plus L is 2L. But the point is, we need to find the wavelength of a single wave. So it will be 2L divided by 2. That is your single, I mean, double harmonic. Can you tell me what is the value of lambda in I mean in the form of L if there are three harmonics?
L a one and one and a half.
2.5. Let's see. Let's check it out. Yes, it is basically 2.5, not 2.5, 2/3. Because actually, why 2.5? The point is, check it out here. How many loops are there? One, two, three. So basically, this is complete one and this is complete one. Technically, we have two, one and two. So two, and then there are three loops, one, two, three. So you divide it by three. So 2/3. Understood?
Sir, I don't think I can see your screen.
You can't see it? Wait, wait.
Yeah.
Why it's like this? Wait. Okay. Now can you see? Wait. Can you see that now?
Yeah.
Okay. Now check it out. What actually I wanted to say. If you see this three layer, what is a full string? If I say this one, the red one which reaches here will be equal to L, and the blue one which come back will be equal to L. So what is the total length here? 2L.
Yeah.
And now 1, 2, 3. So you divide it by 3. So basically now lambda will be equal to 2L divided by 3. Now do you understand?
Yeah.
What if there are 4? This is full 4. So it will be 4. And divided by 4 will give you L. Yep. Divided by, this is the fourth harmonic. 4 nodes and 4 antinodes. So why it give you 1 by 2? What is the reason for this? Mm, wait. This is half, this is full L, then 1, 2, 3, 4. Oh, yes, it's 2 upon L. So it will be 1 by 2 L. Now check it out what actually is happening. First one is 2L, then you have L, then you have 2 by 3L, then you have 2 by 4L. What exactly is happening? I mean, how the actually things are going. Now check it.
Wavelength decreases.
No, I'm not saying wavelength is decreasing. Check it out. 2L, then you got L, then you got 2 by 3L, then you got 2 by 4L. Can I write it like this? 2L over 1. Can I write it 2L upon 2? Now see that 2 by 3L, 2 by 4L. What will be the next?
2 by 5L.
Yes. And then 2 by 6L.
2 by 6.
So now you can generalize your formula, technically speaking, that for nth number of harmonics, what will be your solution? I mean, what will be your answer? 2 is common, but
2 and L.
no, see, 2 and L is common. So the formula becomes 2L over. Now this is for one loop. This is for two loop. This is for three loop. This is for four loop. So what shall I place here? If I want to find out for nth loops, I place n here. So this
N.
is, yeah. So this is the formula for nth loop of the harmonics. So this is the generalized
Sir,
formula.
I'm confused in the fourth harmonic.
What is the confusion? Tell me.
So the red one, it
Hmm.
completes a full wave
Hmm.
by the third loop, and the blue one does too. So
No,
there's an extra like
see. You
loop
don't.
at the end.
No problem. Let's check it out. No, I'm not talking about in this one. Don't be confused with the loop or anything. Just see one thing. This is a complete one string L, because definitely the L is full. This one. So it means L is going there and L is coming back. So technically speaking, the length is same. That is 2L. Now, how many loops you have? One, two,
Yeah.
three, four. So this is your technically lambda equal to. Now, do you understand
Yeah.
or still confused?
I get it now.
That's good. So generalized formula is this 2L upon N. If I ask you, or if the question asks you, for example, they give you the values and everything, and they say the length of the string is this much, and they ask you what is the wavelength of, let's suppose, 12 loop of a standing wave, you will use this formula straight away. 2L divided by N, and that give you, or you can, they can might be ask you, what is the fifth harmonic or sixth harmonic? Now, very interesting fact is, when you say second harmonic, then how many nodes and how many antinodes are there?
3 nodes, 2 antinodes.
So you just need to remember that antinodes are always one less than the
Yeah.
nodes. because nodes is always be at the ends and NT nodes are always be at the peaks. So always one NT node less. It should have more, but
Yeah.
it will be always one less. Like in case of two, it will be one, two, three, four. They are saying two. Why? Three nodes and two NT nodes. Why they are saying three nodes? Three nodes are fine. One, two, three. Yeah, that's fine. But why two they are saying? Okay, they are considering one, I think. See, they are not considering one as an individual. This is the one. Same thing, this is the one, I believe. Yeah, they are considering both the peaks as one. Okay, so always remember
Yeah.
the NT nodes are one less than the nodes in all the, what you call it, all the questions. All right. So do you understand this is
Yeah.
standing wave small topic?
Yeah.
I want
Suppose
to,
I have a question
please, please.
and it tells me like the length is 6 centimeters and there are like 12 loops. So it will be 6/12 to get the wavelength, right?
Now, remember that they will not ask you like this. They will not say there are 12 loops. They may say there are 12 harmonics. Now, if the 12 harmonic they are talking
Okay.
about, it doesn't mean if they are asking you the 12 harmonics, then you will simply apply a formula 2L over 12. That's it.
Okay.
They may ask you a question that how many nodes are there, how many NT nodes are there, or they may ask you the distance of it. How will you find out the distance between two consecutive notes if there are two, if there are, sorry, 12 harmonics, let's suppose.
It will be 12/L.
It will be,
That will give
one,
you,
yeah, it will be length upon 12. Simple, not 2L,
okay, yeah.
because it will be just the length divided by the total numbers, because we are finding the loops. Loops mean the distance. Distance will be simple if there is a full length, let's suppose. If, for example, I have to ask you, there are two loops there, then what is the distance two consecutive NT nodes are? You will simply divide it by two.
Yeah.
That's it. And if they ask you what is the distance between two consecutive NT nodes, same thing, divided by two in
Yeah.
case of two. So basically, this kind of question you need to be ready. We will do that question once we finish with the topic. So do you understand that?
Yes, sir.
Okay, that's good. Now let's start with the same thing related one, and we called it interference. Is it? Okay, interference. It's almost the same, but there is a small thing which is actually different in this. This is called Young double slit experiment, which is actually is a part of it. This is especially named as, previously we were talking about constructive and destructive interference, but here we will definitely talk about it. What exactly it is? To be able to explain what is interference and coherence, the one you were talking about, now we will talk in details. What is meant by interference, first of all? It's the same thing as superposition, but by doing superposition, you will get two kind of results which you already talked about. One kind of result will be that you will get a constructive interference. The other kind of result will be that you are not getting the constructive interference, but you are getting some destructive interference, right? When do you get the
Yeah.
constructive interference?
When crust meets crust, trough
Yes,
meets trough.
yes. And same thing, if for example, when trough meets crust and crust meets trough, we are getting destructive interference. Now, very interesting fact. Interference is a special case of superposition where the wave that combine are coherent. The wave overlap and form a repeating interference pattern of maxima and minima areas. If the wave weren't coherent, the interference pattern would change rapidly and continuously. What is meant by coherence? Waves which are of the same frequency wavelength, polarization, and amplitude, and is a constant phase relationship. A laser is a coherent source, but a little bulb is not. Now, this is very interesting fact. What exactly they are saying? Let's talk about. This is one wave. This is another wave. Are they coherent? Yes, Manu. Are they coherent?
No, they have different amplitudes
They have
and
different,
frequency.
yeah, so different amplitude, different frequencies, and might be possible the polarization and amplitudes are different, and is constant phase relation. Constant phase relation means one wave is ahead of other or one wave is behind some other wave. So remember that if this will be the case, there will be an interference. That's not a point that interference will not happen. So I mean superposition will be there. But interference means that two waves must have coherence. If they have a coherence, then and only then we will be able to define that interference. So basically, interference is a special case of superposition where waves that combine are coherent. So two waves should have same wavelength, same frequency, and they are same polarization and amplitudes. Then and only then that kind of superposition is called as interference. Otherwise, we are not talking about the interference. We are talking about the superposition. The waves overlap and form a repeating interference pattern of maxima and minima area. What does it mean? That when waves actually overlap each other, they will definitely do maximum and minimum area. The maximum area means constructive interference. The minimum area is destructive interference. All right. If the wave were not coherent, the interference pattern would change rapidly and continuously. Now, this is very important thing. For example, if they are not coherent, right, then you will not get the same interference all the time, but you will get different interference in different time periods. So you cannot examine what you actually want to examine. Because what happens sometimes, you will examine one interference, then you will not examine the second one because we believe that both the waves which we study are coherent and they may have some sort of phase difference or something, but they're coming from the same sort of source and you can say they have same frequency, same wavelength. Then it's easy for us that we will examine one or two their interferences and we do not need to actually study the further interference. But in case of non-coherent one, the results will change continuously and we will not be or we cannot be studying the phase difference or something like this. Understood?
So, sir, a normal light ray, yeah, a normal light ray that comes from the sun, that's not coherent source,
No,
right?
no, 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 no. See, coherent source is always a laser light. Remember that.
Yeah,
Why laser light? Because laser light has a single light source with a single frequency, and this may be coherent with the other one. But remember that for coherence, we need the same light even. Even two different lights are not coherent. Okay, because
yeah,
once we will be studying the young double slit experiment, you will find out that even the two different, I mean, even the two lights which are coming from a different source, even the laser lights, we will not actually, wait a second, I will show you that the thing which I really wanted to, uh, yeah, here, check this out. If it opens, see, this is the wave, this is the end they are talking about. This is the point. We will discuss it once again because NT nodes and nodes, right? This is the same thing, five
yeah.
wavelength and everything. Okay. And calculation how many wavelengths in there. We will inshallah do it tomorrow, but I just wanted to show you a thing which is very important. Principle of superimposition, we will revise it. Here, the constructive and destructive interference. So this is your no. Where is the one which I actually I want to find out? This is stationary waves and everything. Wait. Okay, harmonics and we upon we have to talk about this as well. It's in detail, right? So we will do that. Okay, frequency of the first harmonic and the second one required. Okay, investigation of the standing wave. It's not there, I believe. It should be there. Should be there. Just a second. Okay, so we were talking. So you do not have a light. You shouldn't have a light which actually divide into multiple colors. That light will not be used for the interference purposes. That should be a laser light. Now, constructive interference. The path difference between the wave is a whole number of a wave. So wave arrive in phase adding together. Now, this is actually interesting. How that young double slit experiment will be constructed. For that reason, I will just explain you few things. We will do this in more details because there are detailed experiment. What is actually happening is, if you check this out, there is a light source here, single light source. Can you see that?
Yeah.
Now, what happened? We have a sort of a slit or something. That's the reason we called it double slit. From here, the light is passing through. Now, here, let's see one thing. Light has two paths. One path is that, and one path is this. Now, point is when light goes from here, it has to pass through here, and definitely it will pass and it will hit the screen. Okay. Now, point is when light goes from the top slit, which is that path, light will go and light will strike here. What do you think that it may be possible that when light goes from here, or you can say light that if this slit is very near, I will read it, then you will see. In 803, the Thomas Young settled a debate starting over 100 years earlier between Newton and Huygens by demonstrating the interference of light. So basically, Newton thought that light was made up of tiny particles called corpuscles, and Huygens thought that the light was a wave. Young interference of light proves light is a wave, where is Young double slit experiment set up. The two slits act as a coherent source. Now, one of the point is, which is very important in that case, my question to you is, if this light has to interfere with this light, which light has to cover more distance to interfere with the other one? Let's suppose you light is going here, and this light, if want to interfere with this light, what do you think? This light had to cover this distance?
Yeah.
Now, we will find out that if that distance is, for example, some value or something, then when it will be a constructive interference and when it will be a destructive interference. I just want to tell you this one for the time being. We will not going to go by the interference for the time being. Just quickly, it was a quick review for interference. The topic we were discussing is actually, where is it? Stationary wave. So let's quickly see these small numericals related to that. So what is it? Let me just quickly go through. We have already seen odd, I mean, nodes at region where there is no vibration. Antinodes are the region where the vibration are at their maximum amplitude. Okay. So this is the one. Now, what actually I wanted to tell you here, check this out. A stretch string is used to demonstrate a standing wave shown. Now, which row in the table correctly describe the wavelength of L and name of X and Y? Okay, what is the answer?
Length L, it's 1, 2, 3, 5 wavelengths.
Five wavelengths. So, five is fine. And what is it? Check it out. There could be A, there could be D.
X is node and Y is antinode.
So which one is right?
It's A.
But they say C, 2.5 wavelength they are saying. Why they are saying 2.5?
Is it
One,
because there's
mhm.
one full oscillation?
Basically 1, 2, 3, 4, 5. There should be 5 actually, but I don't know why they are saying 5. C. And they are saying one more thing. X part is node and antinode is Y part. Yeah, wavelength is technically, because what is wavelength? Distance between two consecutive nodes or distance between two consecutive antinodes. So consecutive means either you're talking about
Oh,
that
yeah.
or you, so basically that is the reason that's half. One, two, three, and four. Technically it's half, 2.5. Because here, this point, then from this point, okay, now one, two, okay, one, two. Why they are saying this? We will see that further. Okay. So now see what how many waves in the length of the string. So basically, if you check this out, from here to here, this is lambda 2. Why lambda 2? Because at the end of a day, one complete crust will be making as lambda. So this is one half, this is complete half, this is one half, this is complete, yeah, this is 2.5. Do you understand?
Yeah.
So basically, now we reach to a conclusion that technically two complete nodes, or you can say from here to here, this is one complete wavelength. Two antinodes and two nodes combined to give you one complete wave. Okay. So X is a point on the display as node and Y is the point where the distance is maximum. So the correct answer was C. Yes, Manur, any problem in this?
No, sir.
I think we better stop it here. I want you to go through that. Inshallah, when is our next class?
I think it's Monday.
Hopefully on Monday, I want you to go through quickly with the stationary waves because in the next class, we will go through the interference, young double-slit experiments and a harmonic with a new, I mean, sort of a thing. There are some calculation involved in that as well. So we will do the calculation work as well. All right.
Yeah.
So that's it for today and hopefully see you on Monday then. Okay. Take care. Bye.
Yes. Sir, can you share this recording?
Yeah, actually, that's what I do. I'm recording everything from now on. So what I will do, I will record it to me, and but how do I share it to you? What can I do? I will record it and pass it to the our coordinator, and you can ask him, and he will give you sharing and everything. Okay,
Yeah. Okay.
no problem. You will get the sharing, and I will give it a name fully. That standing wave, and all this. So it will be easy for you to actually catch it from there. This will be the first recording related to this topic. So I will give it a name, stationary wave 1.
Yeah.
Okay. Okay, then see you. Take care. Allah Hafiz. Bye.